Number 17, the question asks, find the time necessary for $1,000 to double if it is invested at a rate R compounded annually, monthly, daily, and continuously. The fact that we're starting with $1,000 really doesn't make any difference. We do have in this problem, R is equal to 11%. Okay, so we're going to plug that in the formula. The compound interest formula, remember, is A is equal to P times 1 plus R over N to the NT. We are starting with 1,000, but that really doesn't make any difference in our doubling time. So for it to double, we're going to have $2,000. We have 0.11, which is the interest rate. If it's annually compounded, it's over 1 to the 1 times t, and we need to solve that equation for t. So the first thing that's going to go, we're going to divide both sides by 1,000. So it doesn't really make any difference. Again, it does not matter how much money you have to start out with. The doubling time is going to be the same. So essentially, we're just solving this equation for t. Because the variable's in the exponent, I want to take the natural log of both sides, or a logarithm of both sides. You can either take the common log or the natural log, it doesn't matter. Using the properties of logs, this t comes out front as an exponent. So t is equal to the natural log of 2 divided by the log of 1.11. Getting on our calculators, we have the natural log of 2 divided by the natural log of 1.11. So t is equal to 6.641. Okay, for part B, most of this is the same. The interest rate is still the same. The only difference is that we're compounded monthly, so n is equal to 12. So our equation looks like 2,000 is equal to 1,000 times 1 plus 0.11 over 12 to the 12 times t. And we want to solve this equation for t. So we have 2 is equal to 1 plus 0.11 divided by 12 to the 12t. We're going to take the log of both sides. We're going to divide 12 and this thing, whoops, natural log in here, as a number. So t is going to equal natural log of 2 divided by 12 times the natural log of 1 plus 0.11 divided by 12. Putting that in the calculator, we get t is equal to 6.330. Okay, number 17, part C, we are doing daily compounding, in which case n is equal to 365. Okay, so again, we're looking at the doubling time. As it turns out, it doesn't make any difference the amount. So we have 2 times 1 plus interest rate is 0.11 over 365 to the 365 times t. We want to solve that equation for t. Take the log of both sides. So 365 times the natural log of 1 plus 0.11 over 365 times t. We're going to divide both sides by that number. So we have natural log of 2 divided by 365 times the log of 1 plus 0.11 over 365. And make this look a little nicer, let me erase, if I can. Let's see, eraser is where? Okay, so that's equal to t. We're going to get out the calculator. So t is 6.302. And for part D, we're asked to find if it's compounded continuously. So our new formula for the continuous interest is A is equal to PE to the RT. Once again, we just have a 2 there. We're going to solve for t. We take the natural log of both sides. This time I need to take the natural log of both sides because it's e, so I have to do that. I can't take another log. And so this is 0.11 times t is equal to natural log of 2. We're going to divide both sides by, that's a decimal point there, by 0.11. So the natural log of 2 divided by 0.11 is 6.301. And you'll notice that all of these are around 6 years for this interest rate. So keep that in mind when you're doing these problems as far as a reasonable answer. Let's clean this up a little bit. This is 6.301.